He's from Luno. He's the head staff engineer at Luno. And all I can say about him is he's a fantastic man. I've bumped into him 2 or 3 times in the last few days, and he's a complete star. So I shall leave you in the safe hands of Andrew Wormald. Thank you.
Thank you very much. Appreciate the warm welcome. So my talk is event-driven workflows. There is a touch of AI in and a mix and hidden, just because there's a theme, I'm mentioning it mainly. And it's up to you to find out where it is. That's just a little challenge. So breaking down complexity with Go. Let me just start my little clock so that I don't run over time. But first, context. Always context. So I'm sorry, not a head staff engineer. I would love that kind of role. I'm not really sure what that would be. But a senior staff engineer. And I oversee a technical aspect at Luno around our onboarding, retail and institutional onboarding, our payment rails, so that's deposits and withdrawals, kind of integrations, our rewards product offering embedded in our app, as well as our APAC engineering teams, which kind of do a whole range of things in that time zone. So I mostly focus on foundation level coding, kind of frameworks or kind of source code that really helps within our product engineering space. So that's reaching across more than just the teams that I technically oversee. And the things I'm passionate about and the things I'm involved with is testing and event-driven systems. I know that's really broad. It's almost like, isn't that everything? It's kinda, we'll get into that. And back-end driven UI, which might be a bit polarizing, but this is in some places in our application, we use that tech stack. So a little bit about Luno. We have over 13 million customers globally across many different regions, mostly Europe, Africa, and the APAC region, so Indonesia, Malaysia, primarily. Those are our biggest regions there. And we can see anywhere between 5 million to 40 million USD being traded on our exchange. That's never mind just our broker, which acts with multiple exchanges for liquidity, as well as we safely and securely store your crypto. So not just Bitcoin equals crypto, but crypto of many kinds. And we've got many different crypto offerings. So less about the company and a little bit more about what are event-driven workflows. Well, you might not have ever heard of it. I don't think I'd heard of it until I might have just made another thing, and you might just be thinking, oh gosh, another person made another package. Well, yeah, that's me. So event-driven architecture, you might have come across it, you might not have. Just a little summary, event-driven architecture, you'll often find in the microservice pattern. It's the way those microservices communicate through some normalized way of events. And it helps them respond in real time, trigger actions, not just by polling a database, but responding almost immediately. So what are workflows? Well, workflows are best characterized, I guess, by sequences of tasks or steps. So those kind of main characteristics started popping up, and that it's sequential. That helps it be a little bit more deterministic, a little bit more expected, and often a little bit simpler. If you've ever had a complex thing or challenge or piece of code that you've had to write or a feature, often what you'll do is, or your Scrum Master or your ADL will start coming to you and say, well, let's break down that into a few issues. And you're thinking, oh, some admin, great. But what you'll end up doing is you start breaking down that problem into individual steps. So event-driven workflows is kind of that handshake between event-driven architecture and workflows, at least for this. So some aspects, not all. Obviously, I can't go on and on. This is not about event-driven architecture, but let's list some kind of main kind of benefits of event-driven architecture. So we've got real-time. It's distributed. So we can consume events and messages over many different instances. It's not just co-located on one instance. It's really good at being scalable, and it makes you write loosely coupled code because you're not passing in complex parameters. Everything has to go over the wires, so it needs to be serialized and deserialized. So you can't pass around functions and throw them all over the place. So it makes you write some readable code. Workflows. Well, workflows are best as we've kind of characterized this now. We've got sequential steps. We've got decision making. It really helps for complex business logic. It's deterministic, And often, more often than not, you'll have process visualization. So you have a little nice GUI or UI that you can see everything. And workflows I've often seen in more of a data engineering space, and less so in a kind of software engineering space where you're just solving business logic or writing business logic into the application. So event-driven architecture and workflows coming together. I'm just really merging all of these things and saying, okay, well, we've got sequential steps, decision-making, it's deterministic. We're going to make it so. Process visualization, so you can actually visualize this business logic, this feature, and what it's doing, so it's more readable. It's going to be real-time, or at least close enough. It's going to be distributed, so it can be scalable. It's going to be loosely coupled, and I mentioned scalable. Cool, so here it is. And here is a little gopher, as best as possible to the gopher spec. If you didn't know, I found out yesterday that there is a specification for the gopher, which made some last-minute changes last night, and thank you, Ed, for approving the MR to update that before I was blasphemous. So github.com/Luno/workflow, you can take a look. Don't worry, there's references throughout, so you can take a look at any point. It will be embedded in your mind by the end. So in building this, there were some high-level design decisions made. So with event-driven architecture, you can generally go with event sourcing, or you can go with event-carried state transfer, or event notification. Now, if you want a little bit more in depth, unfortunately, this is not going to be the talk where we go into that. Unfortunately, there's not enough time. But the decision was to go with event notification. So there's no state, there's no data. There's just a foreign ID referencing some foreign object and the type of event. It's pretty simple. You can't really get it wrong. You can't have much serialization, deserialization errors. Pretty much is quite a nice system. But it means that your state lives elsewhere. Then another kind of scope or variable that I really wanted was that you could use any event streaming platform. Well, that's a bit ambitious, but then also any transaction supporting database. Okay, now it's getting a little bit complicated. Why would you not just go for the simple solution, Andrew? I don't know. I just really wanted that. So, and then the way I really like defining graphs and workflows and visualization is through a graph that you can draw. And often I think that is a great way to represent a workflow, is to visualize it, to be able to see it, but also the code needs to be able to know what are the expected steps. And we can dive into that a little bit more later. So the choice was to go with a directed acyclical graph, and we'll go into cyclical and acyclical graphs, but this is to represent the workflow. And then defining a step, which was more in the context of maybe like a verb is like to take a step as opposed to just being like on a step in a flight of stairs, as not just being a single node on a graph, but rather being a from node, having a to node, so you're defining going from one place to another, and then there's that piece of logic in between, the transition. And so this is a pattern often found in state machines. And I'll kind of explain the difference between a finite state machine and a workflow quite simply and a high level just now. So how do we get our workflow represented by this cute, somewhat fluffy, maybe could have made it a little bit more fluffier, gopher? So we have a thing called adapters in workflow, and it means that the entire workflow only interacts with interfaces when it comes to data storage. When it comes to event streaming, it's an interface. When it comes to record storage, it's an interface. When it comes to pretty much any dependency, it's an interface so that you can either use the built-out adapters that are supported, or you can write your own to match your own tech stack. Workflow is not meant to say, this is the greatest tech stack. This is what you should do. This is what it's supposed to be, just something that you can use and breaks down complex business logic. So whether you use SQL, no SQL, there's no debate here. You can go and do it. You can just write the adapter if it's not already there. Whether you want to use Reflex, which is something that we use in-house at Luno, or Kafka, or RabbitMQ, or any other event streaming platform, that's fine. You can write the adapter if it doesn't already exist. Reflex and Kafka already are supported on the package. But at Luno, we use a SQL database for state persistence, kind of storing our state. So we have stateful tables, and we use event notification, and we use reflex, which uses SQL to store the events in an append-only fashion. So still the append-only log style, but within a SQL data store. So that means that we can make those changes over one transaction because they're co-located. They can share it. But with workflow, I introduced a little bit of a problem where we can't share a transaction because you don't know what technology you're using, and definitely them being not co-located on the same technology, they're not going to be able to share a transaction. I'm not going to go write out a whole transaction strategy. So this is called the dual write problem. If you want to dive into more, there's some great content online about it. But basically, we would have our process, the record store, which is your one implementation or one adapter. You would have an outbox, which would have almost a record. It's an append and delete, no update table. So this is where the transaction is required to be supported on the record store. You add the records. These will be updated as state changes, so they're stateful. And then the outbox table, or however you store it, whether it's NoSQL or not, is something that's just creating records, and then the workflow's outbox consumer will go and write that to your event streamer. So this normally means that by the time you've consumed the event, even if you're reading off of a read replica, and it even has maybe some high latency, that change is propagated to its replicas by the time it's gotten to your event streamer. So it might not be that low latency thing that you're looking for. You can write your own event streaming platform. You might be able to do some really cool algorithms to share between instances, an append-only file. And you can go into that, and you can write that yourself. But ideally, on most situations, most people will be using Kafka or RabbitMQ or maybe Reflex. So what is a directed acyclical graph? Well, it means that it goes in one direction, so that's the directed part. That's pretty easy. Acyclical means it doesn't cycle. So it means that you don't revisit a node at any point, which is a rule that, in theory, workflow could be built without. But it helps you force logic that if you're revisiting a node, you might be thinking more of a finite state machine, where you're trying to revisit and update a state and represent that state. Whereas this is trying to represent a process or progress in some form of business logic that can be broken down. So here's an example of cyclical graph. This is where you go from A to B to C, down to E. Don't know why I didn't put that as D, but it kind of is more consistent with the other one. And then 2D, and then all the way back, and then you basically can just go in an infinite loop there, revisiting the nodes. And this is something that you can, as mentioned, find in state machines quite often. So what is a step in workflow? Well, a step has got a from status, it has a to status, and has a function that's kind of joining it, and that is the most simplest way I could visualize it. So that came out a little bit bigger than I thought, so that's actually really good. So if you've got good eyes, if you don't, I do apologize. I try to make this as simple, but I really want to explain this one part. If this is the one thing that you understand about how workflow works, this is it. So this first slide will explain the kind of initial process of loading and triggering the workflow, and then the next slide will explain kind of how it goes in its loops through the steps. Cool, so we start off at number one, where we create a record within that record store, and the status, which represents its current kind of status, set to A for this example, just A and B and C. Now, that would be written to the record store, the record table, and it would be written to the outbox table. Now, the outbox consumer on the bottom right is polling that table, which is obviously fully configurable in terms of your polling frequency and everything. And then that will pull and write off to the event streamer. So now all of a sudden your event streamer has got the events of the changes that have taken place in that record store. And status A consumer, so for each kind of status there's a consumer. You can have parallel consumers that are sharded, and there's a whole lot of configurations. You can dive into that. For simplicity, I'm just going to speak high level. So if you want to know about all the scalable and cool things you can do, go visit the package. It's a load of fun. So status A consumer starts consuming the event stream, and it says, oh, okay, well, this is step which goes from status A to status B consumer. it will consume the event, and then immediately it doesn't go up to number 6, it runs over to number 5. It looks up the record in the store and says, are you still status A? Has anyone changed this? Has anything gotten to you before me? I just need to make sure that nothing's changed. This also helps that if status A consumer errors or constantly retrying, but something actually went through to update that state, it just kind of ignores it. So it says, oh, okay, you've moved on. I'm not going to do anything. I'll wait for the next event. So then, as mentioned, it will either error, so there might be a network failure or there might be some fault, and it will just keep retrying indefinitely, or if you configure it to kind of pause after a certain amount of errors, you can do that. But then it will run its execution that you define, and you'll either tell it to move to status B or just no. Nothing should happen. And if you skip, nothing inside of it really updates. It just kind of moves on to the next event. And then finally, if you choose to move to status B, an update is pushed to the record store, and you start all over again. You go down to the outbox consumer, it gets the update, it writes it to the event streamer. That's supposed to say status B consumer, sorry. And then that consumes the new event, and then it does the exact same pattern over again. And it just keeps going until it ends, until there is no consumer for that final status. So let's make some gophers. Some officially designed gophers, I should say, almost. Not officially, not that kind of official, you know what I mean, specification-wise. So we start with a diagram. I'm quite a visual learner. I also like visually representing things to try and understand the concept or what we're going to build. So we're going to start off, we're going to have some status to just say that we've started this process. We're going to have a name created. We've got our color. We're going to set a color for our gopher. We're also going to define the age, because this is pretty important. We don't want to send underage gophers to work, so we'll either send them to school, haha, or we'll send them to work. Great. So how do we start with this? So we start with an enum. We've got a stringer, just because that's a requirement of the status. The status can be any kind of int. And so here we represent, we've got an enum that we're going to use to build all the steps. So we've got started, name created, color set, age defined, sent to school, and sent to work. And with those are building blocks to define our graph. So we're going to define the gopher. Well, it's got a name, it's got color, it's got age, and it's got school and work strings. Fun. Cool. So we start with a builder. So we define that we use a generic. So we've got our gopher. And this is important because all of that kind of data, that struct, is going to be passed from consumer to consumer, change to change, so you can read data from that object. And then the status is just defining the type that you have that you've built up for your enum. And here we're just giving the workflow a name called GopherCon UK 2024. So here's our first example of adding a step. So we start off with defining the from status, which is status started. It's a pretty good place to start. And then we're going to go from status started to name created. Pretty simple. And we've got a function in the middle. So here we have our logic. We've got a context in the beginning. We've got this workflow.run, which we can access. And then we are expected to return a status or an error. If it errors, it will just retry indefinitely, or depending on your configuration, it might pause the record and move on. Maybe it's something that will just never pass. So we assign the name to Budgie. We're just going to name it Budgie, and we're going to return status name created. Now, you might be wondering, why on earth would you need to, maybe it's more of a code review here, but why would you need to do name created in the function as well as outside? Well, this is to support kind of at the end of defining your workflow, you call build, and it starts building up that graph to do some validation. Also at runtime, it does some validation to make sure that the transition it's about to make is expected by its implementer. So especially when things get a little bit more dynamic and you start pushing these functions out of being inline somewhere else, the readability also improves because now you can see, oh, this is the transition. I'm going from this step to this step, and then I can dive into that function. You can find it quicker and read it better. Cool. So this is also what I mean by a little bit better readability. You can see the 2 steps, and you can see the graph getting built up on the right. So we're going to move on, and we're going to set the color. So similar pattern. We're just setting the color to blue, and we're updating the status. And you can see our graph grows. Then we set the age, and our graph grows again. It's pretty, if there's any pattern recognized this here, you can see it's pretty simple. There's a repeatable pattern. And here we've got a little bit of logic, a little bit more than what we've had before. So this is where we have branching in workflow. So it's where you're not just going to one node, you could potentially go to one or the other. So in this function, in this consumer function, we are writing that if the age is greater than or equal to 18, we'll send them to work. And we'll define the work as finding lost go routines. Fantastic job. Or if they're not 18 or older, they're going to be learning about the mysterious runtime scheduler, which is a fantastic learning curriculum. And they'll be sent to school. And so this is how it's defined at the bottom. I guess it's previously, you can see that it's sent to school or sent to work. And you can see here in a simplified way of how it defines that branching. But what if we want to send the gopher to work after school? Because let's be honest, it's never just one or the other. Business logic gets complicated. Our product managers want to do a little bit more. Maybe want to say, oh, this customer can only do something in so long because the FCA decides we would like customers to be very aware of the risks of getting involved with the product. Well, we can handle that. So the graph changes from just branching out to branching out conditionally, but also with some idea of time to change. Let's say the requirement is that they have to be over the age of 18. So this is where timeouts come in. So you define the graph the exact same way, but here there's 2 defined functions. One, which is called setting the timeout duration dynamically, not statically. So you're not setting a date, but rather you can take the current object, that run, and you can say, okay, well, r.object.age, so we can get the gopher's age, and we can say minus 18, and we can say years till 18. And we can add that time, and it gets put away, out of line of consumption, and it will expire when it's ready, and the next function will execute once that time's out, which is fantastic. So as soon as that gopher turns 18, we're going to populate the work field with graduated school and ready to find lost go routines, and set the status to work. But what about graduation? I mean, let's add in graduation. Why not? Let's add more. So I'm glad you asked, the person at the back. I definitely heard you, and everybody you heard me on video, right? So we've got status name created, color set, age defined, sent to school, finished school, and sent to work. Because graduation is not guaranteed, as I'm sure most are aware. So that's pretty important. Always define your requirements. So here we're going to update our timeout to send the gopher to finish school once they reach 18. And let's add a callback. So we've got steps, we've got timeouts, and we've got callbacks. So maybe that's a webhook callback from a third-party service, or maybe it's on some console UI, you've got some admin that wants to interact. Maybe it's an approve a change, approve adding a role, updating permissions for a user, anything like that. That callback can update the status. So we're going to start with a callback type just to pass in data into the workflow. If your callback doesn't need any data from outside, then you don't need to define anything. Cool, so we've got graduation results, graduated with a Boolean. So here is our callback, similar pattern once again. And this is the call logic in the center. So as you can see, the parameters have changed where we have a reader at the end, io.reader. That's largely because in Go's generics, methods can't have any additional type that the primary underlying type doesn't have implemented on it. So passing in a reader kind of allows you to set the serialization, deserialization that you like, whether it's JSON or Proto or anything like that. You can use and you can just coordinate between outside when you're passing it into the callback and inside. So we start off by reading the reader using io.readAll. Oh, sorry. Then we're going to go to the graduation result. We're going to unmarshal it. We're going to check whether the gopher graduated. And if it didn't, we just skip and move on. And that gopher will stay at that status of finished school. Otherwise, we set the work field, and we update send to work. So then, how would you call that? How do you interact with that callback? So here's an example of outside of the workflow where you're just interacting with it. You got your graduation result type, you're populating the field, you're marshalling it, JSON marshalling, matching what the strategy you're using inside the workflow, converting it into a reader, and then passing into w.callback, which is generally a singleton. So you'll have your foreign ID, you have the expected status, and that it should be at, and then the reader, and then it'll execute, and then the workflow continues. If you've got steps after that, it'll just keep going through those steps, it'll keep rolling out whatever you want. It will just keep adding on and going on. So, oh, there we go, I broke it down. How nice of me. Cool. So that is the overall workflow. We've been able to create a gopher with a name, with a color. We've been able to define the age. And if that age is under 18, we've been able to send that gopher to school, like responsible parents. And then once that gopher's finished school, we've made sure that they got a job, which is also being responsible. Yay, congratulations. I thought that was pretty cool. Okay, maybe not everyone. Thank you, that's it. From there, I would like to just open up to any questions. If you have any questions, the QR code will take you off to the repo. I do have the actual example repo, but I never added the QR code. I didn't really know where to put it. But if you want to know or see the repo of what I've just demonstrated, seeing the test, how the testing support works for workflows, especially working with time and timeouts, how do you work with that within your test functions and not waiting years for your test to pass. It's all on there, and I can share the QR code with you if you just come to the front. So are there any questions? I think there's one. Yeah.
Yeah, it was a great talk. Thank you. One of the bullet points you had for workflows is process visualization. So do you have any tooling to do that?
Yes. So part of the example that I wish I'd got the QR code for is that it's got built-out Mermaid support. So it builds out a state graph in Mermaid, and it's got visualization. So it builds out like a MD file. So you can put it in your README. You can create a little command executable to go automatically generate it for you. But yeah, so all of these slides where it's got that diagram of GopherCon UK 2020 workflow, this is generated with that tool inside the package. So we didn't rebuild a tool, just use Mermaid, Mermaid diagrams, and then this is what gets created, and you can add it to your documentation of your workflow. I would suggest it drastically simplifies communicating, it just providing a starting point, knowing from, being able to tell the difference between the beginning and the end of your workflow, give that context, and then you can dive into the code. Great question.
Thank you for the really cool talk, Andrew. When building this, did you consider other similar frameworks in the industry, like Maestro, Cadence? I can think of a few more of those, but
yeah.
What was your motivation behind making workflow?
Well, obviously, there's always a thought of that initial impulse just to build something and kind of grow and learn something. The main thing that I came across was temporal. But there was just a few, and I think temporal is a great solution. It's definitely scalable. It's tried. It's proven. I think the one thing for me that just didn't fit right is what we needed, especially at Luno, is that we didn't just want to go introduce another system. We wanted to use existing tech stack decisions and be able to build on that, or allow us to at least put something in place where we can change the tech stack and not have to rewrite the business logic. With temporal, we would need to make a technical kind of tech stack decision, and then we would have to start rewriting everything. And if we decide we don't really like the way that it's working for us, that is very hard to undo for our team size. So this was more around trying to write something that is not centralized. You don't need to pay for an instance or run it yourself and manage that complexity. The idea is that it uses existing infrastructure, and it's really more of just a code change, like a pattern. So it should be very similar to how your current system is working, but just kind of encouraging you to break it up into steps. So yeah, that's pretty much my motivation for it.
Thank you.
Hello, thank you for the talk. So it's an event-driven architecture, it's distributed in nature. Is your code distributed or is it centralized?
It is distributed, so it uses a role scheduler to determine on which instances these consumers should run. And that would mean even if you use parallel, so there's an option for the steps and for the timeouts that you can set the parallel count. And then those get sharded over multiple consumers. They each try and obtain a role. So those could be distributed on different instances. So you might have 5, you might shard to 3, let's say. And those could each run on a different instance. So it is distributed.
So do you manage the schemas in one place or is it copied across multiple repos? Your message schemas?
Yes. So so for the schemas, we use a monorepo. So it's not much of a problem in our space, but I haven't really played around with that idea. So
okay.
Yeah.
And I'm asking too many questions, but
Okay.
how much impact to latency does it take for all the hops and database writes?
It depends on your configuration, ultimately. So you are left with the polling frequencies, especially having Outbox consumer definitely adds on latency that's probably not desired when you want to do low latency, but then again, event-driven architecture is not always about like the super fast thing when you're doing sequential processing. It's always about resilience and durability. So you rather go a little bit slower and ensure that the customer gets what they need and making sure that you don't do something multiple times, especially in a financial situation.
Thank you.
I see we've got some questions in the front. I think their arms are getting tired.
Hi, great talk. I'm just wondering, because you mentioned that we keep the state at each step of the workflow, is there any way to, let's say, unwind that stack backward, like register methods that would be the opposite of what you were doing, and essentially roll back all the changes if you, let's say, fail in the middle of it?
No, there's no rollback. You can build, so what we have internally is that we have what's called a workflow UI. It's more internal, it's not put up because I don't want to make front-end tech stack choices, whether it's Angular, React, Vue, going into that world, I'm not going to go into it. But you are, there is something called the run state controller. So you can, I haven't covered it in depth here because it's quite technical around each run has a finite state machine, and you pretty much go from initiated to running. From running, you can go to pause, so you can pause that workflow indefinitely. So it's like a dead letter queue almost. So if you've got a problem with the customer and you want to go change some external data or anything like that, even modify the data that the workflow is using, you can have it automatically pause after a certain amount of errors or manually trigger that. And then it can go from that, and then it can go to various completed states. One thing is also is that it is built to support deleting that data. So you can write a, as part of workflows that you can basically be GDPR compliant by deleting data based on external events. So workflow has a concept called connectors, and that means that you can connect to external event streams different than what it's using. So if you're using Kafka, but the external stream is RabbitMQ, you can consume that, you normalize that in a little function, and then you can go and delete that data. You can say, okay, this customer, I want to scratch all of this data. So that was a very important requirement. And what it basically goes from the final states either completed or canceled, where it can't be resumed. And then from either completed or cancelled, it will go to data deleted. And then from that point on, it's unusable, but the record's there to show that that data was deleted. And you should only have access to the foreign ID. So you could tie it back to a customer and say, well, we ran that workflow, but we can't see the data because there was a request to scrub that data.
Okay, thank you.
Yeah.
Thank you for the talk. I have a couple questions, actually. How would you allow the logic changes?
Sorry?
How would you allow the logic changes for workflow?
How do I allow the logic changes?
Yeah.
I'm not sure if I fully understand the question.
So you have like breaking changes in your workflow logic.
Yes. So normally the safest thing to do is you can set up you can make a variation of that. So even if you are just how you construct the workflow, it's not fully presented here, but normally what you would do is you would put this inside like a constructor where you build the workflow. And then you would have, I don't think I can go back far enough, but essentially what you can do is you can build a variation. And then you start triggering customers to that new variation, and you stop triggering and allow those old workflows just to finish. If you just pull them, there is some built-in alerting, and further alerting would be for records that have just paused and been unmaintained. So here we go. This is the builder. So you could pass in potentially a different name, or you can just, through general logic, just change, be able to assign it elsewhere. But essentially, this workflow will be a piece of memory, and you'll just need to have another piece of memory in some form of singleton that references like v2, and then you'll just use some feature flag to divert the traffic safely to that, and then you allow the processes in place to finish. So normally, there's never kind of if you really want to stop everything, then you can just stop the workflow, and then they're just going to be dangling there. And then if that's kind of the emergency case, sure. If you've got one, you can go to a console. You can build a console very easily because the record store is just pretty much yours to go and interact with. And then, yeah, you can, I would say that's probably the safest migration route. Is just let them finish.
Yep, thank you. And the second question would be, how do you cover the logic with the tests?
Right, so out of the box, there's a lot of testing support because this was written TDD style. So from the very beginning, everything was just test. And then I was like, okay, I'm going to add timeouts. How on earth am I going to test this? And then I started writing support for it. So it's more of maybe an acceptance level testing. There is some tools there to help you provide the parameters for the function signatures, like this workflow.run. Workflow.run is not like a serializable type. It has the run state controller in it. So if you go r.skip or r.pause, it actually does some logic. It updates that record to say, pause, please don't continue. So I've just gone blank on the question, sorry. There's a lot to think about.
So how do you cover the workflow
The
logic?
test. Yes, so then you can write individual unit tests for the functions, but I'm also a big fan of writing an acceptance test for the entire workflow. You want to make sure that you're going from start to finish without caring of what the steps are. You can say, okay, I want to start at this point, I expect to end at this point, and then I expect this output. The example repo for this demo I can show with you has got just pretty much that acceptance test where it starts it has some helper functions to deal with the timing using a clock, and the callback, and then it has a require method, which just says, for this workflow, at this status, I expect the object to look like this. And that's pretty much it. The testing doesn't build out support for you to test other systems or external dependencies or anything like that. It's really just focused on the state you would expect workflow to be in at the end. And then you can write your unit test per function, which is obviously encouraged, because your unit test may fail and you've got no clue where it's gone wrong, right? So this is some basic testing.
Thank you.
Yeah. Thanks for the questions.
Hi, thanks for the talk. You mentioned that the technology you use with this workflow is reflex.
Yeah.
So what advantages or disadvantages does using Reflex give you over using other tools like Kafka or RabbitMQ?
In 2019, you would have had a special session just focused on Reflex. I wouldn't say, I think Kafka's great. We didn't make a decision necessarily, it was quite before my time, that it was really Kafka or Reflex, build our own thing. So it's built out. At the moment, it has a large advantage in that you don't have the dual write problem. It's pretty quick in that sense, so replication also is pretty consistent, more or less. It does scale, surprisingly. I originally had my doubts, but it scales really, really well. But yeah, there's no reason not to go and use Kafka. I think it's largely as we've built a lot of our tech stack around Reflex, and that was our original kind of event-driven architecture coming in to into our services as we started breaking up. We had Reflex be implemented, and now it's actually something that we revisit from time to time. Should we move to something like Kafka? Does anybody have good enough knowledge of Kafka and configuration and running it? So it's definitely, I wouldn't say it's something you should go and use over Kafka. I wouldn't say there's huge advantages. I think it's quite simple. It's easy to manage because it's very similar to how a SQL database works. So you just, and you normally have tools to set up those, to inspect and read and have the kind of access to view those logs, whereas with Kafka, it's a little bit different. So yeah.
Great, thank you.
There's some questions over here.
Yes, thank you for the talk. I just wanted to know that if actually the order of events matters, like you have to fire and process your events in a defined order, does this architecture and code adapt to this kind of constraint?
Because it's event-driven, order doesn't matter. So you are not, we're not really running through that graph at any point where we're traversing it, but ultimately we are just defining consumers. What topic in Kafka or Reflex event type are you listening to? And then that is defined by that from status. That is largely going to be set up along with the workflow name, the type, and then some configuration options will define the event stream that it listens to. So order doesn't really matter. It's all about when you trigger the workflow, you can specify where in the workflow you would like to go, but you need to know you can only move forwards. So yeah, that's pretty much it. The order will be consistent to what you've defined here.
Thank you.
Yeah, hi, thanks for the talk. It looks really nice. The question I have is how mature is the solution? How long are you using it in production environment for? And also a follow-up, at what scale? Is it like the main pipeline of the company?
That's a great question. So at the moment, this is a passion project that I'm pushing for just so that we can have most of our business logic separated from a technical design, like a tech decision, infrastructure decision. At the moment, this is still maturing. This is still pre-1.0. So this is pretty mature. This started, okay, not that long ago. It's been a concept that I've been pondering in my mind for quite a few years. I played with Temporal, played with another tool as well, and I've been trying to figure out. This has mostly come from a concept that a pattern that we've developed at Luno using a finite state machine and Reflex, and the tools kind of just defining this kind of event notification and kind of this pattern, and this really removes a lot of the boilerplate, plumbing, and everything. So this is still very early days. We've got it running in our production code. It currently is used for processing all of our identity provider reports and everything like that. So it's definitely used in a critical path at Luno. If it doesn't work, it would mean that we would not be able to onboard any customers because they wouldn't be KYC compliant. So it automates our entire report reading and then basically translating that to updating certain elements of our system. I mean, it's scaling fine at this point. Onboarding is normally not as, it's not like our exchange or our brokerage or anything like that, where we wouldn't normally put something like this. We're trying to put this in a place where we've got more complex business logic, where we're waiting on external dependencies, different events, adding connectors maybe to trigger the workflow, or waiting for an external event to continue the workflow. The next iteration is to use it in our payments integrations to manage like batch processing of withdrawals with various different banks that have different strategies. They expect different kind of ways of interacting. Some do instant withdrawals, some don't. Some expect to file at a certain time. So, and one thing I didn't cover, maybe too in depth, is that it also supports scheduling with normal cron spec. So you can schedule a workflow to run every single day at a specific time, or at any kind of frequency. So it's definitely getting there. I think most of the syntax has pretty much started to relax. There's definitely more. I think the next phase is all getting into performance related. So it's all about just finding better ways of writing the internals. I think the API is pretty much just done. And feature set is definitely done. It's not gonna, I'm not a fan of expanding beyond this. So that's the one thing I'll gatekeep on is what it can do. It probably shouldn't do much more than what a basic workflow system can do. Yeah, I hope that answers your question.
Yeah, it does. Thank you. Yeah, again, it looks really nice.
Cool.
Thanks.
Yeah, don't go build your entire company on the thing just yet. I'm pretty confident in it just from seeing production results and the time and the resilience of it. It's been really impressive, but as any engineer, I've got this deep, deep, deep fear that this is solely inadequate. So please, just calm my own fear and you play around with it, maybe use it for one or two things, and join the community on GitHub. So yeah, can't really go to the end now. Otherwise, I just click. Are there any more questions? Yes.
Thank you for the talk. I want to know if there is any problem of duplicate events or messages. If so, how do you handle that?
Great, that's a great question. So part of it is built-in idempotency. So if you've managed to update the state, but then somehow there's a duplicate event, by the time you are consuming that in next event, you are going to read from the record store and see that that status is updated. If it hasn't, the idea is that you should always try and write idempotent code. Like at any given point, nothing is purely idempotent, right? So it's very much going to depend on you being quite wise, realizing that you've got some starting ground, but it's not going to protect you from everything. So the Outbox consumer can definitely somewhat push in new events if it fails to delete the record or some. But I haven't. It's run a lot in production, and I've analyzed and gone and tried to find duplicate events, and it hasn't done so yet. So I think the chance is really small. I haven't actually calculated the probability of it. But yeah, the main thing is that all consumers should be idempotent. This provides a baseline idempotency. At best it could at this level. Thanks. Any other questions? Cool. Is there another one? Lights are bright. I didn't realize I left like basically half the talk just for questions. It's like, this is probably your biggest fear. It's like, write some code and then leave like an hour for questions. Yep. Yes, go for it.
Yep. So thank you for the presentation. First question is, why did you choose Golang to write this as opposed to any other language?
Because I love Go. I mean, it couldn't be simpler to write it in Go. It's got concurrency, it's got consumers. I mean, if I want to build anything, I'm going to write it in Go. I absolutely love Go. I am normally very level-headed around just, tech is just like, it's just a means to solve a problem. But since interacting with Go, I have formed the one bias I have really had is just I want to work with it so much because I find it so simple to read. And compared to some other languages that I've just had headaches with, this is just so fun. And it's never made me love my job more. So that's my reason. Yeah.
That's cool. Thank you. The next question was, how long did it take between designing this and actually getting it into production use?
Just about, well, it's had different iterations. So it's gone through some internal booking system that we have at Luno for managing our office spaces around the world and reserving desks and everything. So that went in a very early version that was on my own GitHub repo. just to trial out and getting some more kind of legroom. So mileage, not legroom. Jeez, what am I flying? So yeah, it's been about a year, but I mean, it's been in production for quite a few months now. So maybe like August. So about almost 8 months it's been in production. So yeah, I would say 7 months of development, designing. A lot of it just kind of started with the basics, just steps, no timeouts, no callbacks. I didn't have this it kind of iterated and became and improved. And there was a big point where I pretty much rewrote the internals because I started with event sourcing. So you just needed one kind of database technology. But I didn't like that, and I really wanted to support event streaming platforms separate, and then it kind of iterated from there. So yeah, just under a year. As a kind of a side thing, this is not my main work. But yeah, it's been well supported by the company.
Thank you. One last question. What challenges did you encounter whilst doing this as a side project, and how did you overcome them?
I like that question a lot. I think the dual write problem really had my head scratched. I hadn't come across it. I'd been in this space where I'd just been working within transactions, being able to write a record or update a record and write an event to a table. So learning different event-driven architecture patterns, learning the names of them really, you're kind of always kind of aware of how to do it like this or that, but getting familiar with the names, diving a little bit deeper, reading tons of books. I just picked up this biggest hobby for reading, and now I've just got like a stack of books that I'm slowly getting through. But yeah, I would say the dual write problem was really interesting, and then you have to kind of pick one of various solutions. My favorite is the outbox pattern. It's slower than the rest, but it is definitely the most, I think, robust and resilient out of them. Yeah, and some are just plain out crazy. Like listen to yourself feels like a very crazy pattern. But yeah.
Sweet. Thank you very much.
Crikey, I can't believe it. We've actually got to the end of the questions. I would like to say, Andrew Wormald, Senior Staff Engineer at Luno, that was fantastic. And those were really some of the most lively questions that we've had over the last couple of days. So that was completely fantastic. Can we have a big GopherCon 2024 round of applause for Andrew Wormald?
Thank you, everyone.